أعزائي طلبة وطالبات الثانوية العامة القسم العلمي رياضيات لغات، أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج داينامكس. النهاردة إن شاء الله هنستعرض مع بعض exercises on نيوتن second law. هنشوف إزاي نقدر نطبق حالات نيوتن second law ونشوف الفورس بتاعتنا function in velocity ولا function in time ولا function in displacement، وكل كيس منهم أقدر أشتغل بيها بالطريقة المناسبة ليها. Dear students of grade 3 secondary, welcome to our program today. Today we have dynamics. Our lesson today is exercises on Newton's second law. A train of mass 220 tons moves along a horizontal straight railroad with a uniform velocity of magnitude 29.4 meter per second during the train's motion. The last car of mass 24 tons is separated and moves with a uniform retardation to stop completely after 1 minute of the separation moment. Find first the magnitude of the resistance per ton of the train's mass, supposing it is constant. Second, the magnitude of the force of the train's engine. And the third required, find the distance between the remaining part of the train and the separated car at the moment the car is completely at rest, given that the remaining part of the train moves with a uniform acceleration. First, study the motion of the separated car from the laws of rectilinear motion. The mass of this car equals 24 tons and its initial velocity v naught equals 29.4 meter per second, and the velocity of it after 1 minute equals 0 and t equals 1 minute or 60 seconds. Now we use the units second for time and meter per second with velocity, and must be used the unit kilogram to the mass. Since v equal v naught plus at, then 0 equals 29.4 plus the acceleration of the car times 60. Then the acceleration A equals negative 0.49 meter per second square. The acceleration here equals negative value. Then the velocity of the car is decreasing till the car come to rest after 1 minute. From the equation of motion of the separated car, we know that the force which acts in this car is the resistance and in the opposite direction of the car motion. Then negative R equals M times A. M, the mass of the car in kilogram, and the acceleration A in meter per second squared. Then negative R equals 24 times 1000 times negative 0.49. Then the resistance equals 11,760 Newton. The resistance now in Newton units. Then R equals 11,760 divided 9.8 kilogram weight, which equals 1,200 kilogram weight. The resistance now for all mass of the car. But what is the resistance per each ton? R equals the resistance, the total resistance, 1,200 divided the mass of the car, which is 24 ton. Then R equals 1,200 over 24 kilogram weight per each ton. The resistance for the 1 ton equals 50 kilogram weight, or R equals 50 kilogram weight per ton. Now, what is the distance traveled by the separated car within a minute after separation? The train moves with a velocity 29.4. Then the initial velocity of the car is 29.4. S equal V naught T plus half AT squared. Then S equals 29.4 multiply T. T equals 1 minute or 60 seconds plus half time the acceleration, which equals negative 0.49 multiply the time in second power 2 or 60 power 2. Then by calculate this formula, then S equals 882 meter. Then the separated car traveled a distance equals 882 meter till it come to rest. The second required, study the motion of the train before separation. The train was moving with a uniform velocity before separation. Then the mass of the train equals 220 tons and the resistance equals 50 kilogram weight per ton. Then the moving force equals the total resistance. The moving force F equal the total resistance of the train equals 50, which is the resistance per each ton, multiply the total mass of the train, which equals 220 ton. Then the force equals 11,000 kilogram weight. This force acts on the train. Now, the third required, study the motion of the remaining part of the train after the last car has been separated. The mass of the remaining part equals 220, which is the mass of the total mass of the train, minus 24, which is the mass of the separated car. Then the mass of the remaining part of the train equals 196 tons. And the force act on the body or on the remaining part, F equals 11,000 kilogram weight. And the resistance equals 50 kilogram weight per each ton. What is the equation of motion of the remaining part? The remaining part moving under the action of two forces. The engine force, F, and the resistance force, R. And we know that F minus R equals MA. F in the same direction of motion, then it's positive, but the resistance R in the opposite direction of motion, then the resistance R in negative direction. Since F minus R equals MA, then 11,000 times 9.8, 11,000 kilogram weight times 9.8, then the force here in Newton unit, minus the resistance 50 multiply the mass of the remaining part 196 ton times 9.8, then the resistance now in Newton units, equal the right hand side 196 multiply 1000, the mass of the remaining part, in kilogram times the acceleration. Now the acceleration must be in unit meter per second squared. Then the acceleration equal 3/50 meter per second squared. And from the laws of motion, since S equals v naught t plus half a t squared. Then the distance s equals the initial velocity of the remaining part equals 29.4, which is the uniform velocity of the train before the separation moment. Then S equals to 29.4 times 60 plus half times the acceleration 3 over 50 times 60 power 2. Then the distance S equals 1872 meter, and we can now calculate the distance between the remaining part of the train and the separated car at the moment of its rest. The distance equals 1872 minus 882 equals 990 meter. Then 990 meter is the distance between the remaining part of the train and the separated car at the moment of the separated car at rest. Another example. A body of unit mass under the action of three forces. F1 vector equals AI vector plus J vector, and F2 vector equals I vector plus BJ vector plus 3K vector, and F3 equals I vector plus 2J vector minus EK vector. If the displacement vector S is given by the relation S vector equals Ti vector plus half T power 2 plus T J vector plus 5K vector. Find the value of each of A, B, and E. Now we have three forces act at a body. The mass of the body equals 1. Then the resultant of these forces equals F, and F equals vector F1 plus vector F2 plus vector F3. Then vector F equals AI vector plus J vector plus I vector plus B J vector plus 3K vector plus I vector plus 2J vector minus EK vector. Then F equals, vector F equals A plus 2I plus B plus 3J plus 3 minus EK. This relation F vector is the relation of the force or resultant force acting on the body. The displacement vector of this body vector S equals Ti plus half T power 2 plus Tj plus 5K vector. Now we know that Newton's second law, F equals ma. M is the mass and A is the acceleration. The acceleration A is the derivative of V with respect to time. V is the velocity. What is the velocity? The velocity V equals the derivative of S with respect to time t. Then vector V equals the derivative of vector S with respect to the time t. Now vector V equals the derivative of Ti equals 1I, which is I, plus the derivative of half T power 2 plus T equals T plus 1 J, and the derivative of 5K equals 0. Then the velocity V vector equals I vector plus T plus 1 J vector. Now, what is the acceleration? The acceleration A vector equals the derivative of vector V with respect to time t. Now A equals, vector A equals, the derivative of I, 1I equals 0, and the derivative of t plus 1j equals 1j. Then vector A equals vector j. Since the mass of the body equals 1 and the acceleration equals j, we know that vector F equals m multiply vector A, Newton's second law. This form using if the mass of the body is a constant. Here m equals 1 unit, then it's constant, and the vector F equals m times vector A. Vector F is A plus 2I plus B plus 3J plus 3 minus EK equals the mass of the body, which equals 1, multiply the acceleration vector, which equals J. Now A plus 2I plus B plus 3J plus 3 minus EK equals 1 times 0I plus J plus 0K. Then A plus 2I equals 0I. Then A plus 2 equals 0. And A equals negative 2. The second term, B plus 3J equals 1J. Then B plus 3 equals 1 and B equals negative 2. The third term, 3 minus EK equals 0K. Then 3 minus E equals 0 and E equals 3. Another example. A force F acts on a body of mass 1 kilogram at rest, moving in a straight line starting from the origin point O on the straight line. And the force F equals 5x plus 6, where x is the distance between the body and the point O measured in meter and F measured in Newton. Find first the velocity of the body v when x equals 4 meters. Second, the displacement s of the body when v equals 9 meters per second. Now, the body at a distance x meter from the origin point O and at rest. A force F equals 5x plus 6 act in the body in the direction of motion, and we know that ma equals F. M, the mass of the body, which equals 1 kilogram, and the acceleration A of the body equals F, which equals 5x plus 6. Then ma equals 5x plus 6, and we know that the acceleration A equals v dv dx. And when the mass equals 1 kilogram, then 1 multiply v dv dx equals 5x plus 6. Now, the integration of v dv from v naught to v equals integration of 5x plus 6 dx from 0 to 4. What is the integration of v dv? Yes, v power 2 over 2, or half v squared from 0 to v. And what is the integration of 5x plus 6? 5x power 2 over 2 plus 6x, or 5 over 2 x power 2 plus 6x from 0 to 4. Now, half v power 2 minus half 0 power 2 equals 5 over 2 times 4 power 2 plus 6 multiply 4 minus 5 over 2 times 0 power 2 plus 6 times 0. Then the integration of the left hand side equals half v power 2, and the integration of the right hand side equals 64. Then v power 2 equals 2 times 64 equals 128, and the velocity equals positive or negative square root of 128, which equals positive or negative 8 root 2 meter per second. The second required, A equals V dV dx, and the mass equal 1 kilogram. Then 1 times V dV dx equals F, which equals 5x plus 6. Now, integration V dV from V naught to V equals integration 5x plus 6 dx from 0 tx. The integration of V dV equals half V power 2 from 0 to 9. And the integration of 5x plus 6 dx equals 5 over 2 x power 2 plus 6x from 0 to x. Now, half 9 power 2 minus half 0 power 2 equals 5 over 2x power 2 plus 6x minus 5 over 2 times 0 plus 6 times 0. Half times 9 power 2 equals 81 over 2 in the left hand side, and 5 over 2 x power 2 plus 6x in the right hand side. Multiply both sides by 2, then 81 equals 5x power 2 plus 12x. This trinomial equals 0, 5x power 2 plus 12x minus 81 equals 0. Then the two values of x equals negative 27 over 5 or x equal 3, which is the displacement of the body when the velocity equals 9 meter per second. Another example. A force acts upon a body of mass 250 gram moving in a straight line starting from rest. At the origin point O on the straight line, and F vector equals 5t minus 2I vector plus 4tj vector. If the force F is measured in Newton unit and the time t in second unit, find the velocity v vector and the displacement s vector in terms of the time t. Now we have the force F in terms of the time t, 5t minus 2 in direction I vector plus 4t in direction j vector. Since vector F equals m multiply vector A, where the mass equals quarter kilogram, the mass of the body equal 250 gram divided 1000, then 250 over 1000 equal 1 over 4 or quarter kilogram. The mass must be in kilogram because the velocity in meter per second and the force measured in Newton and time in second. Now, F, which equals 5t minus 2 multiply I vector plus 4t multiply j vectors equals MA or quarter vector A. Then the vector A equals 20t minus 8 in direction I plus 16t in direction j, after we multiply both sides by 4. And we know that the acceleration A equals dv dt. Vector A equals derivative of vector v with respect to the time t. Then the derivative of vector v with respect to time t equals 20t minus 8 in direction I plus 16j 16t in direction j. The integration of dv vector from v naught to v equals integration 20t minus 8 in direction I plus 16t in direction j dt from 0 to t. This relation, integration dv from 0 to v equals integration 20t minus 8 in direction I plus 16t in direction j dt from 0 to t, and the integration of the left hand side equals v. Vector v equals integration of 20t is 10t power 2 minus integration of 8 equals 8t in direction of I plus integration of 16t is 8t power 2 in direction j from 0 to t. Then the vector v equals 10t power 2 minus 8t in direction I plus 8t power 2 in direction j minus 0. Then the vector v equals 10t power 2 minus 8t in direction I plus 8t power 2 in direction j. Now we know that the vector v equals the derivative of vector s with respect to the time t. Then ds dt equals 10t power 2 minus 8t in direction I plus 8t power 2 in direction j. The integration of d vector s from 0 to s equals integration 10t power 2 minus 8t in direction I plus 8t power 2 in direction j dt from 0 to t. What is the integration of ds? Yes, vector s equals the integration of 10t power 2 is 10 over 3t power 3, and the integration of 8t equals negative 4t power 2 in direction I, and the integration of 8t power 2 is 8 over 3t power 3 in direction j from 0 to t. Then vector s equals 10 over 3t power 3 minus 4t power 2 in direction I plus 8 over 3t power 3 in direction j minus 0. Then the vector s equals 10 over 3t power 3 minus 4t power 2 in direction I plus 8 over 3t power 3 j. And we note that the velocity v and the displacement s, the relation between them and the time t, or v and s in terms of the time t. بكده اعزائي نكون استعرضنا مع بعض exercise on نيوتن سكند لو، وعرفنا ازاي نقدر نستخدم نيوتن سكند لو، ونشوف الكيسز المختلفة بتاعته، ونشوف امتى نستخدم الاف in terms of x او الاف in terms of t او الاف in terms of v. كل واحدة منهم ليها انتجريشن مختلف وطريقة مختلفة في الحل، لكن هي دي الكيس اللي ممكن اتعرض لها وانا بشتغل في هذا النوع من الاكسرسايز. By these examples we come to the